Hi, this is Mr. Ward, and we're going to consider PreAlgebra Do Now 35.3. So you know a triangle contains 180, and you probably know a quadrilateral contains 360 degrees. So how many degrees do a pentagon and a hexagon contain? Well, it turns out there is a formula for this. If n is the number of sides, we multiply that, subtract 2 from that, and you multiply that times 180. Okay, and think about that for a triangle. There are 3 sides, minus 2, so 1 times 180. For a quadrilateral, 4 sides minus 2, which is 2, times 180. So for a pentagon, we would say 5 minus 2. So it would be 3 times 180, which would be 540 degrees. For a hexagon, we're going to say 180 times n minus 2, so it's going to be 6 minus 2, so that'll be times 4. Okay, and 4 times 180 is going to be 720 degrees. Okay, so both those are degrees. Okay. And that will be useful when we're working out a formula for finding the area of any regular polygon, because you're going to need degrees. So we're working with trigonometry, and you can find the height of the triangles. You can split that into. Now, given the tangent is the ratio of the opposite side over the adjacent side, use this information to find the height, not of the tree, of the isosceles trapezoid. Obviously, I have to make a correction there. Okay, so we have 38 degrees. It's an isosceles trapezoid, which means these two legs have to be the same, which means this is 25. Okay, so we're not going to be using the tangent. Again, I have to correct that. But we are going to use, if we want the height for 38 degrees, that's opposite, and we have the hypotenuse, which is 25. So we're going to use sine, because sine equals opposite over hypotenuse. Okay, so opposite over hypotenuse. Okay, and so then we're going to have the sine, and shorthand for sine is sin. Sine of 38 equals height over, we could say dE over 25. And then we can multiply both sides by 25, and you get 25 times sine of 38 equals dE. So let's figure out what is the sine of 38. And I'm going to go to a calculator for this. You could, of course, go to your table on this. So sine of 38 degrees is 0.6156. So we're going to call it 0.6157. Okay, and when we round it, and then we're multiplying that times 25. So let's actually just multiply times 25, and we will have a pretty good answer for this, about 15.39, 15.4. Okay, so we can just say equals 15.4 units. Hey, what about the area of this figure? What about the perimeter of it? Well, this figure is made up of quarter circles. So let's count the quarter circles. 1, 2, 3, 4, 5. So this is 5/4 of a circle that has a radius of 8 centimeters. So area of a circle equals pi times radius squared. And we have 5/4 of that, okay? And we have 5/4, so we're going to say 5 over 4 times the area of a circle, and 5 over 4 here. And our radius is 8. Whoops, you can see that again. Our radius is 8, so we're going to say 8 squared. All right, so it's 5/4 times pi times 8 squared. So let's copy pasta that into the next line, and 8 squared is 64. And we want to do 64 times 5 over 4. I'm going to factor out 4 from 64 and from the 4, so that becomes 16. and that becomes 1. And so it's 5 times pi times 16, which is 80 pi centimeters squared. That's the area. Okay, how about the perimeter? Well, the perimeter is 5/4 of the circumference plus these 2/8. So perimeter equals 5/4 circumference, I should say, plus 2 times 8. And the circumference, so 5/4 of the circumference is 2 pi times r, and then plus 2 times 8. Okay, so let's work out 2 times pi times r. Well, r once again is 8, so it's 5/4 times 2 times 8. That's 16. Okay, times r, or times pi, I mean. And then that's plus 16 as well. So what's 5/4 times 16? Well, we can cancel out a 4 in the top and bottom, and that ends up being 5/1 times 4 pi plus 16. And so that's 20 pi plus 16 centimeters. Or more properly put, we would usually put the rational number first, plus 20 pi centimeters. And you are done. I hope that was helpful.